Welcome back, everyone. In the last video, we have implemented our instructions as well. Right now, we are actually ready to do this process instruction and get all the actual implementation, the business logic of the instruction. In order to save time, I'm going to copy and paste the imports. Then we have our own state, so this greeting account is not necessary. This entry point is necessary for all of the smart contracts or programs we are going to implement, so I'm going to leave it. I will delete the implementation here, the boilerplate. Then we can start with our own implementation. We are going to use instruction data as well. So let's start with instruction. And this is going to be review instruction.unpack. So we are going to give the instruction data, the U8 vector to our unpack function, the question mark, and we are going to get the actual instruction. This can be of two types. First one is review instruction add review. We are going to get with title, rating, and description, and we are going to give them to our own add review function, which doesn't exist yet, but soon it will. So it's going to get program ID, account, title, rating, and description. Similarly, we are going to have an update review, same parameters, so we can just delete these. And instead of add review, we are going to call update review, which also doesn't exist yet. Let's start with add review. So this add review is going to get the parameters we have defined here. First of all, it's going to get a program ID, then accounts, then title, rating, and description. It's going to return program result. First of all, we need to iterate through the accounts to see if we get the correct ones. Let's create account info iter, just like what we have done in the CPI transfer. So it's going to get iterable version of the account. And the first one is going to be initializer. And we are going to get its next account info. The second one is going to be the PDA account, which PDA account is going to actually store this review. Question mark, and we need to get system program. Since we are going to create this record, we actually need system program for this. We are not going to need it in update review. All right, so let's see. First of all, let's check if the initializer is equal to, if it's a signer or not. And in case no, we are going to return error with program error, missing required signature. We need to make this none. So if it's not a signer, we are going to return this error. And after that, let's come up with PDA and bump seed, just like what we have done in CPI transfer. So we are going to call find program address. The second one is program ID, that's true. But the first one, the seeds, is the initializer. So we are going to get initializer.key as reference. The seeds is also going to get title as bytes, since the title is going to be the unique feature. Since we don't have an ID, this title needs to be unique for every review. So let's get title as bytes and as ref. So this is our seed. This is what makes it unique, and this is where it's stored. Also, one final, not the final, but a check we need to do is if PDA not equal to PDA account key. So in case this is true, we are going to return an error, which is our custom error, program error, invalid argument. And the last check, we are going to see if the rating is higher than 10 or less than 1. So in this case, we are going to return another custom error that we have defined in the earlier sections, which is invalid rating. But since it's custom, it didn't suggest. Now we can make this review error instead of program error. And after that, we are going to need an account length, since we are going to be creating an account. We need the length for it, which is of type uSize. And we need the rent as well. We are going to use rent.get, so nothing fancy here. And let's do rent lamp ports, which are required for defining an account as well. So minimum balance, and we are going to give account length. And now actually we are ready to create a PDA account. For this, we are actually going to use another CPI, another cross-programming invocation. This time we are going to call system instruction to create an account. So invoke sign. The instruction we need is system instruction. And inside that, we need create account. We need this variable. From key is initializer key. 2 is PDA account key. And this lamp port is what we have created called rent lamp ports. Space is 1000 as we have defined in account length. So let's try into. We have created the account length and we are going to try into with unwrap. At the end, the owner is going to be program ID. We have defined the instruction. So we need the account infos next. For this, we are going to give reference with an array containing initializer.clone along with PDA account.clone. So basically any account that is involved in this transaction, not system instruction, but system program.clone. All right. And the last one, the signer seed is again the reference, the double reference actually, initializer.key as ref. Title as byte as ref, and the bump seed. All right, it looks good now. So we have created a PDA account. With this invoke signed, actually we can start modifying the account data and serializing it to store it on the blockchain. So we need a semicolon here now with a question mark, since we are not entirely sure this is going to work. And in case it doesn't, we need to have our checks for that as well. So let's get account data, which is going to be equal to try from slide on check. We are going to get this from account state with our PDA account. We need to get this data borrowed from PDA account, and then we need to unwrap this. Not like this, because what we need to unwrap is actually the try from slice uncheck. With this, we are attempting to get an account state, and in case we do the unwrap, in case it is successfully unwrapped, let's call it that way, we are going to check if this account state is initialized. So if this is already initialized, we need to return an error saying that we cannot initialize it one more. Since this is add rate, not update, we are going to return error, which is program error, and it's called already account already initialized. In case this is also not the case, we can actually start the heading review. We can add the title, description, and rating to the account data that we have just serialized. We are going to set is initialized to true, since this is the first time we are initializing. And now we can just deserialize, not deserialize, serialize this account data and store it in the blockchain. And for that, we will use the familiar syntax of PDA account data.borrow as mute, since we are going to be changing. And hopefully, when this is all done, we are going to return an OK response. Actually, this concludes our ad review, and let's do a build to see if everything is working. So we have the warnings and the error saying that the update review is not in scope, and it's true because we haven't implemented it yet. In the next video, we are going to do that.